Alright, looks like we're live. Hello everyone and welcome to yet another Azuzin session. So let's make a little bit of an announcement and officially start the stream. Any minute now. Just a second. Right. So Red Circle live on Twitch. And what are we doing today on twitch.tv? We're doing today a Rust web development. That's exactly what we're doing today. Isn't that cool? Isn't that epic? I think that's pretty freaking epic. So let me actually give the link to the Twitch chat where we're doing all of that. And there we go. The stream has been officially started. So today we're going to continue developing the thing that we started on the previous stream, which is basically like a local search engine. Right, you can find the source code here. I'm going to copy paste this thing in the chat, and for people who's watching on YouTube, this thing probably going to be uploaded to YouTube. You can find it in the description. So the idea of this thing is to actually develop like a general tool that, given a folder, will index that folder and will allow you to search within that folder using something called TF-IDF, right? So TF-IDF, it's basically a term frequency inverse document frequency, right? So essentially it's a relatively simple formula, which, given a term or a word, can tell you how much value that word or term carries in one specific document. Right, so we have a set of documents, you have a certain term, a certain word, and you can say, okay, so how relevant that term to that specific document, right? And the way you can organize the search is that you can make a user enter a prompt. You can then split it into terms, tokenize it, and then compute the relevancy for each individual document for each individual term and sum them up. And then you'll get a document ranking, right? So you'll get a value that tells you like how relevant that specific document to the prompt that you entered. And then you can sort the documents by that specific ranking, right? So in that way you can sort of search like similar to how maybe like web search engines works, but these days web search engines use some sort of like a patented secret AI shit. I don't know. This is how they used to work. This is like an OG style of searching, and that's what I want to implement, right? So we started to develop that on the previous stream, and we already developed a tool that, given a folder, can actually index it, right? So it can go through each individual document, right? And then in each document, it can collect all of the terms, all of the words, and count their frequencies. So we can collect that information. We don't use that information yet. So today's stream is going to be about making a use of that information. So I was thinking what kind of interface I'm going to have for this application, because right now it doesn't really have any interface, right? And I was thinking we're living in 2023, right? And 2023 is the year of web development, right? Is it? I don't know, whatever, doesn't matter. So what I was thinking, I wanted to develop the interface similar to something like Syncthing. Have you guys heard about Syncthing? Syncthing, right? It's sort of like a local Dropbox, right? So it's a local Dropbox. You can start this application. It's running on your local machine, right? It is running on your local machine, but yet it has a web interface. And the way you're supposed to use that web interface, you go to localhost, the port of this thing, you open up website, and you control the web application running on your machine through the website also running on your machine, right? So it's kind of convenient. So it creates like a cross-platform sort of UI. You don't have to worry about it, and also you don't have to use Electron, right? Because it's kind of like a weird idea of using Electron. You're just installing a second browser. Why not make an application just serve the web pages so you can use whatever web browser you want? Yeah, so like why installing another web browser? That doesn't make any sense. just do it like the Syncthing. I mean, why not? And that's what I want you to do today. Like I want you to make use of the index that we collected for a particular folder, and also just implement like a simple web page that asks the ask for the prompt from the user and display the results in the web interface. And all of that using Rust, by the way. All of that is using mother flipping Rust. Isn't that cool? It's one of the liked languages on the internet, according to Stack Overflow, that nobody uses because we have ChatGPT. Anyway, I'm sorry. So that's basically the plan for today. Right, basically make a simple web interface and make use of the indexing that we actually implemented on the previous stream. So that's basically the idea for today's stream. So we'll get a couple of subscriptions and stuff like that. So let me quickly acknowledge them. So I suppose from here, Zvone Codes, thank you so much for tier 1 subscription. Thank you, without any message, but no message is required. Junior Fretos, thank you so much for tier 1 subscription with the message, yeah, baby. Yeah, baby, indeed. So, Skyrus Velox, thank you so much for Twitch Prime. And Anonymous Gifter gave 5 community sub. Thank you. Really appreciate that. Really appreciate all of the money given to the Jeffrey Bezos. He really needs all of those money. So we're gonna start with picking the web framework that we're gonna use for the web interface. So since this web interface is supposed to run on the same machine as the server, right? We don't need anything super hyper performant, super hyper parallelized and stuff like that, because those kind of frameworks with, you know, fancy websites and shit and like huge community and stickers and stuff like that, they tend to be very overbloated for what we are about to implement. What I need to do, I need to have a simple application that listens to the TCP port. And when connected through the TCP port, I wanted to give an HTML, and that HTML may query more additional JavaScript code, and that additional JavaScript code will occasionally, on the same machine as the server, on the same machine, occasionally just check some things. Do you really need a hyper-performant, hyper-parallelized, huge framework with a huge community and a lot of fancy stickers that you can put on the MacBook? I don't think so. It sounds like an overkill. Right, so I was looking around through like what I can use for this kind of thing. I was maybe initially thinking to actually implement my own like HTTP server, but it's kind of eh. So I found a very cool thing that kind of fits exactly what I want. Right, I found a thing called Tiny HTTP. Right, so Tiny HTTP. Right, and what's funny is that like other frameworks kind of use this thing. I think another framework that uses this thing is called Royal, and it's relatively popular, but I mean it doesn't really add that much to the whole thing. So the entire thing is just this, right? So you start a server, right? You start a server, and then the server had methods that gives you an iterator of incoming requests. And you basically iterating through incoming requests and handling them, and you can basically respond with a response. And that's it. That is freaking it. Like, this is precisely what we want, right? So it's just, there is nothing else. And usually, as far as I know, it's like designed to be used by other bigger frameworks, but we really don't need bigger frameworks. That's literally everything that we'll ever need, like everything. I'm not even sure if we need HTTPS, right? So because I plan to run the interface on the same machine as the backend, that's the general use case. And for that specific use case, do you even need HTTPS? It's just like, why? Right, maybe we will have a use case when the actual server is running on a different machine and you check in the interface from another one. In that case, as far as I know, this thing has a feature to support HTTPS. Right, so it's not that big of a deal, so you can just slap it. So yeah, there we go. So HTTPS, and as far as I know, it like supports different like encoding, like encryption libraries, including Russell's. Right, which is basically OpenSSL replacement. Yeah, here's the Russells. OpenSSL replacement written completely in Rust. Right, so completely in Rust. All right, So let's go ahead and just give it a try and see how we can utilize this thing. Right, so this is going to be cargo, add tiny HTTPS. Not HTTPS, what the fuck am I talking about? HTTP, tiny HTTP. So let's, of course, update the crates index. Of course, update crate index. And here are the features, I suppose, like, oh yeah, I remember this thing actually denotes what features are disabled or enabled by coloring them. Yeah, but in this particular place we don't really support the coloring, so you can't see that. It's actually kind of funny, right? So if I actually remove it, right? If I actually remove it and go to, I keep forgetting the name of this thing, and do cargo add tiny HTTP. Right, so it adds the colors in here. Oh yeah, when it actually uses the feature, I think it adds plus, so it doesn't really need the coloring in this particular case. Okay, that's fine. Okay, so let's take a look at the application. So I cleaned up the application the other day. I introduced the notion of subcommands, right? I introduced the notion of subcommands. Now, if you want to index something, right? So here is the JSON index. Let's actually quickly remove it. So I'm going to do cargo run. Right, so of course it needs to rebuild everything because we added dependencies and shit like that. Alright, so as you can see, there's two subcommands, index and search. So, but the search right now, it only checks how many documents are in index because searching is not implemented yet, right? This is how I envisioned it is going to work. Maybe we're going to add another subcommand, something like serve, right? So you do serve and you provide the index file and it starts the HTTP server and use that specific index file. So let me show you how it's going to work. So you do run index and let's say you want to index. So here we're using as an example the docs.jl, right? Docs.jl is a website with documentation for OpenGL and stuff like that. It has a very rudimentary search thingy and I'm trying to make something more smart. Right, so, and for instance, I want to index the GL4 documentation, right? So here we have XML stuff, and let's go, right, so we're going to do run index docs.jl GL4, right? So, and as you can see, it's going to go through all of these things, and it's going to try to index them. All right. So it's going to take some time because, I mean, of course, it's very difficult to parse XMLs, right? You need some time. And then it creates the index.json. So, and here we can actually check how many like documents were indexed. Right, so it will say 328. So interestingly, like off screen, I very quickly implemented indexing recursively. So that means you can actually say, okay, index like everything in all of the subfolders of this thing. And it will actually go ahead and do that. What's interesting is that it only works with XML documents, right? So for instance, it encountered the Python code, right? And it said that it couldn't parse this thing. In the case when it cannot parse the file as an XML document, it basically tells you that I cannot parse that and ignores it and continues to index it until it indexes everything. Right, as you can see, it just continues. Like there's a lot of, it went into .git, right? It went into like inside of the Git history and stuff like that, and it just keeps going. Right, so whatever it can index, it will try to index, and whatever it cannot index, it will just ignore it and move on until it indexed everything. So that's basically how it's gonna work. In the future, we're gonna support like more different formats, more documents, and stuff like that. Maybe I'm gonna just implement a thing that ignores everything that is not XHTML. I think that would make sense, right? So to not waste time on the things that are not parsable, because you can actually detect that through the extension, right? Hello everyone. How are you guys doing? So we're just waiting until it just indexes everything, because I want to index it once and not re-index it again, right? And we're going to be using the same index for testing things, right? And as you can see, it finished now. It's saving the JSON index.json. And the size of the index.json was 684 kilobytes, so now it's actually 3 megabytes. right? So this is a 3 megabytes JSON. And if we check that specific index file, right? So it should contain roughly, so even parsing this thing is kind of slow, 1,611 files. So it's basically indexed 1,611 documents, right? And we're going to be using that to test things around. And narrative, I hope I pronounced your nickname correctly. Thank you so much for tier 1 subscription with the message hello lads. Hello, hello indeed. Welcome, welcome, welcome. Alright, so we have an index that we can use for different stuff. In the future, I actually kind of plan to maybe replace the JSON index file with something more usable. Maybe Sqlite database, right? So the cool thing about using like Sqlite database file is that it's a memory database, right? Which persists on the hard drive and stuff like that, doesn't require any database server, and you can use like external utility to look inside of the database, right? You not necessarily have to use your own program to understand what's going on in the database. You can always use external tools to do this kind of stuff, right? To actually check what's inside of the database. Alright, so let's go ahead and create a subcommand, right? So let's take a look at the usage. So I have a little bit of a usage in here, which explains different commands that you can have in here. And let's create serve. Right, so the serve should start the HTTP server. Start local HTTP server with web interface, right? So with a web interface. So, and we're gonna just do it like this, serve. And let's say this thing is not implemented. So let's try to do run and see if we have the subcommand now, right? So serve, if I run serve, it will say that this thing is not implemented yet. Okay, so maybe I'm gonna start the local documentation. So this is gonna be doc, and I'm gonna open it. As far as I know, it doesn't really open anything, right? But at least it gives me the path to the file that I need to open myself, right? So documenting everything. So all of the dependencies. And I really like Tiny HTTP because look, this is basically all of the dependencies that we have, including the transitive ones, right? So there is no serde in here, but I wonder, yeah, so if we do something like clean, right, and just build stuff one more time. So I just want to take a look at all of the dependencies. Maybe there is a command that shows all of the dependencies, but I couldn't be bothered, so. Right, so we don't really have that many things. It's actually quite a few. It's actually a few of them, not quite a few. English is weird. Because few is a low amount of things, quite a few is a big amount of things. Is that how English works? I think that's how English works. It's kind of weird, right? Don't you think? Right. So let me do run. What I was wanting to... Yeah, I wanted to do doc open. So this is going to be this thing. Might as well maybe just copy paste this example from here. Right, so we need a server and a response. So I'm going to put this stuff in here. So this is a server and response. So we need to create this server, right. It creates the server on this specific port. So what I'm going to be doing, I'm going to listen to only to the local connections, as I already mentioned, and I think I'm going to use the default port as 6969. So maybe another thing, we can try to accept the address from the user, right? So address, something like this. So args next, but we can make it optional. I think it would make sense to make it optional. Right, so let's actually indicate that this thing kind of accepts an optional address. Right, something like this. And this is going to be like a default address, right? So here we have next, and then unwrap or this thing. So this is an address, and then we can do something like this, right? So in the server HTTP, right, server HTTP, I suppose returns some sort of error. HTTP. So what kind of error does it return? I just want to take a look at that. So it returns the result, which is part of the, it's a part of the result, just a regular result. I thought maybe it's like a local alias for this kind of thing. And the error that it returns is just a boxed error. It's just like whatever error, right? So what I usually like to do with this thing is just like unwrap them. Right, so so maybe I'm gonna map an error. I'm gonna just instantly report it, and then just unwrap it like this. So here I'm gonna do something like could not start HTTP server on maybe at, and we're gonna provide the address, and the reason why we couldn't start it is here. There we go. So this is the server. And there we go. So the next thing we need to do, we need to start handling the incoming requests, right? So for request in server incoming, or fucking incoming requests. There we go. So essentially we can create a response. So this is the logging, right? So this is kind of a login. I'm not sure if I want to like log too much. From here, like I don't think it makes sense to log headers, right? So well, I'm not gonna do that. Let's not log any headers. Emacs, what the hell is going on with you? Holy shit. All right, so what do we have in here? Okay, so this is that. Maybe I'm gonna also indicate that this is in for, like an opposite to an error that we log in here, right? Sometimes we log errors, but this is more of an info. Right, and we need to prepare the response, right? So we need to prepare the response, and the response can be constructed from a string, right? So let's say hello world. Freaking okay. And now I can do request, and I can respond with a response, right? So it's more of a, yeah, it's called response as well. So I suppose this thing may also return an error. Does it return an error? I don't know. Let's see. What are you doing? Let's do run. Maybe not even run. But yeah, let's do run because it's not going to do anything. Okay, try using thing conversion, blah blah blah. But I expected this thing to be a string actually. But so address is going to own it anyway. Okay, that makes sense actually. So let's actually do toString. Right, so it's going to own this stuff, and no method name respond. Right, so let's do respond. What else do we have in here? So we have a thing. So address is borrowed. Interestingly, I think it makes sense to actually pass it by a reference, so it's not actually moved. And this thing does in fact return an error, which we may want to actually report, map error. And here's an interesting thing. Do I really want to like quit after that? Right. If an error happened during responding to the client, maybe it makes sense to just continue doing this thing. Yeah. So let's actually do something like unwrap or else. All right, and let's do e-println error could not serve a request, right? Because of this reason. But since we unwrapped it, it's not going to stop. The loop is going to go for the next request, right? So we just try to respond it couldn't do that. Next request, and so on and so forth. Right, so let's try to run this entire thing and see. Okay, so now it does serve. You know what I want to do? I'm gonna also print some sort of info, listening at HTTP, and we're gonna provide the address like so. Right. So let's do serve, and here we go. Listening at that specific place, and hello world. Look at that. Wasn't that super simple? That is it. that is freaking it, right? So do you need anything else? So if you take a look at all of the changes that we made, so we added like a small tiny little dependencies. In terms of transitive dependencies, this is how much we added. Really not that much. And this is the code that initializes the web server. Like, no need for like Tokyo or whatever the fuck people use or anything. It's just like, yeah, you want to serve some HTTP, there you go, just serve some HTTP. And especially if you're not doing any overcomplicated shit and if you don't need like a super web scale, Google style web scale, it's just like, yeah, that's how we can do that. Simplicity, simplicity. People forget about simplicity. Alright, so, and we can actually respond not only like with this thing, we can try to respond with, I don't know, with the actual HTML. So, we can try to serve a file, right? As far as I know, you can do that in here, right? The response from, what is that? From file. You can serve a certain file, and it doesn't set the content type, but whatever. But you can basically write HTML right in here. Who said you can do that? Like Rust row strings, right? Rust row strings. So I don't remember how to do that. Row string literals. Google. Why are you so bad? Why are you so bad? I'm asking you for a very specific feature and it's incapable of instantly showing me how to use that. It's fucking embarrassing. It's fucking embarrassing. There we go. This is what I was talking about. Right, so you just do R and something like this, right? So, and you close it with this thing. And you can just put the fucking HTML in here, right? So let's do HTML. Right, so HTML. So there's a head and title and body, right? If I remember correctly. I don't remember, you know, HTML. I'm not a web developer, right? I'm not a web developer. So title. So what's the name of the project? It's a C Roost. It's a search engine in Rust. And then here we can do something like hello world. And as far as I know, it should not work, right? If I understand this entire shit correctly, this is not going to work. Okay, so it's actually kind of funny that it requires these things. Right, so let's actually restart the entire thing and refresh. As you can see, it doesn't work. Precisely because it doesn't set the content type, right? So we probably have to set the content type ourselves. And if I remember correctly, you do something like with header. Yeah, so let's do with header. Right, so let's go. I wonder if we can just indent all of that a little bit better. 1, 2, 3, 4. Because we can serve it with the indentation. Who said that it's bad? The web browser literally doesn't care. 1, 2, 3, 4. Right, so then we can close this thing like so. Right, there we go. So we can just have HTML right in here. Maybe I'm gonna even close it like so. So this is the response. And we're going to do with header, but I don't remember how to construct a header, right? So anything that is convertible into a header, and what do you have a convertible into a header? So how many into do we have? Into a vec. So maybe there is some sort of a constructor, so you can do from bytes, and this is anything that is convertible to bytes. I wonder if I can just like header from bytes, right, and just do content type. And what's the content type for HTML? Content type HTML, something like text HTML, if I'm not mistaken, right? I'm not a web developer. I know nothing about web development. Don't get me wrong. It's just like that's why I Google such basic shit, because I literally have no idea how to write HTML, CSS, or any shit like that. So there's also like a char set or something. Right, so this is like me literally writing a web page for the first time ever. I have no idea, like this is very new for me. I've never done that before. Okay, so I hope that the string literals are convertible to bytes, right? So we're gonna assume that they're convertible to bytes, and because of that it's going to work more or less. All right, so this is the content type, and let's try to compile this entire thing. Right. Okay, so header is not found, and let's import the header, right? So let's see if it's going to do that. So what do we have? Header, you may even have some problem converting this thing, which is rather weird. Required by unbound introduce, wait. Trait from result. So doing from bytes actually may introduce some problem. Okay, so let's unwrap this thing, I suppose. Expect that we didn't put, let me actually do something like this and just think, that we didn't put any garbage in the headers, right? So because I suspect the only reason why this will fail is because we just didn't construct the header properly. Maybe because of that it would make sense to do something like let content type HTML, maybe like text HTML. Right, so let's just put it in here. Alright, so this is the text HTML, and we can just do content type text HTML. Let's try to compile it one more time. Okay, so it compiles, run, serve. Alright, so let's go in here. Boom! Dab. Isn't that epic? Isn't that freaking epic? Holy fucking shit. So you don't even need to put like a HTML files in the project or anything like that. You don't need any webpack or anything. You can bake a string literal with HTML into the executable of the web server. Just take a freaking HTML and fucking bake it right into the web server and just fucking serve it. Just fucking serve it. It's that simple. Why people overcomplicate shit? I have no idea. Do really people take me seriously? I don't know. I mean, I just need to ask very explicitly, is it obvious that I'm saying all of that with half irony, at least? Or do you really think that I am like that? Yes, I am like that. Anyway, so I'm more of like making fun of people that overcomplicate things when it's not needed in majority of situations, right? So if you need to do a very simple thing, you can just do a very simple thing. That's it. Anyway, because I'm just a little bit afraid I'm just like making fun of all of that shit, and that somebody's gonna look at me for the first time and think, what a fucking idiot, like what the fuck are you talking? Maybe I am an idiot, who knows, I don't know. Alright, so this is what we have, and what's interesting is that we can start putting some, some things like query, and then we need to have an input field. How do you do an input field? I don't remember. HTML input field. Right. Oh, you literally use an input field. Who would have thought? Okay, so today we're learning HTML with Zozin. Type text. Okay, so the type is equal to text. So maybe you want to even have some sort of ID. Right, so in here we're going to say, okay, it's a query. Right, it would be kind of cool if it actually automatically recompiles. So this is probably one of the reasons why you want to save it into a file, right? So this is one of the reasons why you probably want to have something like index.html. Because it will make it just easier for you to edit this entire stuff. Right, so let's put it like this. And then, so from file, I suppose, and when we serve in from a file, what does it accept? Does it accept just a path? I don't remember. Response from file. Right, so what did it have? So it supports literally files, so you have to probably do something like file open. Right, so you need to do open. And what are we opening? We're going to be opening index.html, but here is the thing, it may fail, right? So this entire thing may miserably fail. So let's create something like index.html file, right? And here we're going to do map error, and we're going to simply say, actually unwrap or else, right? Unwrap or else, because I don't want to stop the server just because we couldn't open a certain file, because maybe you deleted the file, right? And then you put it back, so you don't need to restart the server because of that. So it doesn't really make much sense, right? So index.html path, we're gonna put this stuff index.html path, right? So I'm gonna put it like that, and eprintln like so. Error could not open, could not serve file index.html file because of this error reason, right? And oh yeah, that's very interesting. So unwrap or else, and what I want to do actually in this specific case is continue serving the request, right? I want to kind of, if it failed, just continue serving, just continue serving. So I wonder what would be the best way to do that. Well, the best way to do that would be to actually put that inside of a separate function, right? Just put it inside of a separate function. Okay, let's quickly do that. So let's create a function serve request, right? So where we are going to accept the request, maybe by a mutable reference, request. And we're going to return result, right? It doesn't really return anything, and I don't really care about the error, right? So here, like, I recently started to do the following idea is that when I need to report an error, I actually handle the error as soon as it happened inside of the function, and I only bubble up the fact of an error happening. You know what I mean? Right, essentially, if some sort of an error happened within the serve request, I can handle it within the serve request, but it would be kind of useful for the caller of the serve request to know that something wrong has happened there, right, to maybe skip an iteration of the loop or something like that. But you know that whatever happened there was handled there, basically logged somewhere, notified the user and whatever. So I don't really care about the specific error, I just only care about the fact that an error has happened. So this is my paradigm of working with the errors in this specific project. So a good example would be something like parse entire XML file, right? So essentially this thing opens a file and tries to parse it as an XML. But if an error happens, for example, during opening a file or during parsing the file, I just log it there and I just bubble up the fact of error happening, but I don't tell the error because I already logged it. And the loop that iterates through each individual file within the folder recursively, right, it only cares about the fact of an error happening, and if an error happened, what it does, it just goes to the next iteration of the loop. Right, it just skips it. It doesn't need to handle the error, right? The only thing it needs to know that an error has happened, right? And in that case, you just like, oh yeah, let's try another thing. Oh, something bad happened. Oh, let's try another thing. But what needs to be logged is already logged closer to the place of the error happening. So this is basically my paradigm of working with the errors with this specific project. Does it make sense? Right? So because it's always easier to like handle the error closer to the place where an error has happened, because there you have more context to handle it, right? So, but if you want to do something more than just logging it, well, you probably need to design that up front, because here I don't know if I want to do something more than logging it, so that means I'm not going to even try to do more than just logging it, because it's trying to develop architecture before you even know what you want, right? So in this specific case, I want to just log it. Let's just log it. If you will need something else in the future, you can always just replace an error with a custom error and just work up in the level of abstraction and just modify things like that, right? So it's better to be very specific upfront until you gather more information about what you need to do, right? So So I'm just like explaining why in this specific case I return like this thing, because if something bad happens inside of it, I'm just gonna log it in there, but for the caller of the function, I'm gonna notify them that something bad happened. All right, so let's actually go ahead and move serve request. And in here, specifically in here, we can in fact just do that and bubble up this thing. Map error, and there we go, and then I can do okay. And that's basically it. So serve request, so we're doing for, we just serve the file, could not serve the file. So in case of the couldn't serve the file, we probably want to even return like 404, right? So it would make sense to return 404. All right. Oh, that's actually pretty interesting. So when I'm responding, do I actually move the response inside of it, or can I pass it by a reference? That's actually very cool, because maybe I can have predefined responses like 404, right? Just predefine it and then just like always return it, but I don't think so. So what do we have in here? Request response. Respond, not response, but respond. And you actually move it inside of it. Yeah, you actually move it inside of it, so there's nothing much you can do here. Okay. Whatever. All right, so serve request, and let's go serve request, request. And in that case, I just like, just don't do anything. I just want to ignore it. I wonder if I can just ignore it. I don't quite remember. Okay, so let's go through. Yeah, you have to cannot find a request, so that means I need to do tiny HTTP. Okay, what do we have? So when I'm responding, I actually move it inside, so that it probably makes sense because of that to actually really move it inside. Request not found in the scope. Oh, it's a require request. All right. Index.html file, local variable similar. Yeah, path. So response from file, we're gonna provide the index.html file, right, index.html file, and that is basically it. Right, so I can refresh. So here is the query, and there we go. So I can now open this entire stuff and provide your query. Right, we can do something like this, and as you can see, it actually refreshes. Isn't that poggers? Isn't that freaking poggers? I think it's pretty freaking poggers. All right. So you know what? I want to make a small break. Small break, and after the break, we're gonna continue serving these things. I think we also need to serve the JavaScript, and as soon as we serve the JavaScript, we can actually query back to the server and ask the server to do some things. So let's quickly do a break. All right. So one of the things we'll probably need to do, we need to implement the router between different resources, right? So because we're gonna be serving like different resources like index.html and also index.js and some different API calls and whatnot. So let me do the following thing. I'm gonna just take a look at what kind of URLs we get. Right, so here you have, this is basically the info that goes into the router, right? It goes into the router, and then we serve the corresponding response or do request and whatnot. So that should work, I suppose. We can already kind of see like what's going on in here. So let me restart the entire thing. Let's go here. It doesn't work. I'm surprised why. Right, so because I actually did nothing. So this is just that. And the page is not working. It's currently unable to handle this request, so it returned 500. That's kind of funny. Right, so if I do index.html, right, so if I do index.html, it literally returns index.html. And then if I do index.js, it literally returns index.js. So for now, we can actually hard code like literally this combination of methods and URLs and just serve the corresponding files. So let me quickly do that, because I don't really plan to like have patterns, right, or anything like that. For now, at least. In the future, we'll see if we'll need something like that. So when we get a request, all right, so when we get a request, we can get the method, but what method actually is, right? So request, where is the method? Method, okay, it's a pointer to something, and what that something is enumeration, so that means I can actually like match these two things. And I wonder, okay, so if URL is a string slice, can I actually just like do pattern matching to just like choose where to go? It's a URL, so that means I should be able to do some interesting thing like request method, right, request method and request URL, right, so I'm matching those and I'm gonna say, okay, so this one is get, right, but I will probably also have to do something like method get, and here we have the URL like this, right, and this is where we're gonna return the index thingy, right, this is where we're gonna return the index thingy. In case of anything else, we can always return like a 404, right? So we can always return 404. Right, so if this is something else, just return 404, and in that case we don't really need to return, well, I mean, we can just, yeah, we can put OK in here, so we don't have to put it anywhere else. Request respond response from file, maybe from string, and let's do 404, and I think in the response we can say with status code, right, so I can specify the status code, and code is something that is convertible to status code, and status code is a structure that contains U60 right, so it's Rust developers are Java developers in disguise. It's just instead of instead of like abstract factory beans, they have you know, numbers that are wrapped in a structure and also implemented like into a trait for them or something like that. They also like layers of abstractions of abstraction of abstraction of abstraction. Yeah. Java developers in disguise. Just like, you need to just provide a fucking number. No, you can't just provide a fucking... Wait a fucking second. You won't provide just a number? In 2023? Status code. Okay, with status code 404. Right, so we're gonna do response. And yeah, we can actually do something like that. Interestingly, we may actually start returning whatever is returned by the response. That's actually a very interesting idea. Serve a request, which is rather interesting, but yeah, so this is 404. Okay, so let's try to build. So there is no method, use of undeclared thing method, right? So that's another thing we need to have in here, and also status code. Status code. There we go. So it kind of works, surprisingly. So let's give it a try. We're gonna do serve, run serve, and yeah, it works because I'm trying to query index.js, right? So, but if I try to query this thing, it does work. If I query index.html, it doesn't really work. And maybe this is something that we also going to do. Right. Serve request. So this is a serve request. And I wonder, like, I remember that you can specify like several of these things. Is that how you can do that? Right. because I don't quite remember. Right, I don't quite remember. Let me see. So does it compile? Yes, yes, yes. Okay, so this is just index, and this is index HTML. And then if you want to have JS, you can't have that yet. Right. So now we can do method get index.js. Right. So this is index.js, and there we go. Here we're going to be serving the index.js file. So let's actually create index.js. Right, so in here I'm gonna do console log hello world. Right, hello world. Okay, then. So what are we going to do? I'm going to copy paste some of this stuff, right? Content type text HTML, JavaScript file content type. I think it's something like application JS or something. Text.js, there's application JSON. Okay, so let's go with text JavaScript. Right, so let's go with text JavaScript. Can I also say that it's a char set UTF-8? I think I should be able to say that it's a char. It's char set UTF-8. So text JavaScript. So this is a text JavaScript. Might also index HTML, index.js. Right, index.js and query. Wait, why did it? Let's see. We replace index HTML with index.js. There we go. Is that working? Is that working? Okay. Right, what do we have? So this thing does not exist because it has to be a JS JavaScript. There we go. Alrighty, so let me see. So if I try to do JS, there we go. So this is JavaScript and then HTML, and if it's something else, it's a 404. Okay, that's perfect. So now we want to probably go to index.html and maybe use the script out of it, right? So src index.js, and I wonder if it's going to work, right? So it's kind of interesting because I never provided slash in here. I think the browser is gonna like you know, do all of that correctly, hopefully. Right, so let's open the console. Let's open the console, and there we go. Here's the hello world. Right, so and now I can go to full bar. Right, I can refresh this entire thing, and here we go. Here's the full bar. And all of that is done with a tiny HTTPS. Tiny HTTPS. Isn't that poggers? Isn't that poggers, my dudes? So what I'm thinking is that so request is kind of mutable. Maybe it would be nice to have just a function, something like serve static file, right? Serve static file where you just provide the request. Right, you provide the request, you provide the file path as the str, and you provide the content type. You provide the content type also as str. Right, and in here we may probably like return result like so, and just like tuck this repetition under this function, if you know what I mean, like literally like that. So like so. So here we have that content type header, right? So this is a content type header. Here we can just provide the content type like so. So we're gonna expect that we didn't put any garbage in here. So this is the file path, right? So that means just we have to use the file path in 3 places, right? File path. Oh, that was kind of weird. We can remove that. Now this is the file that we're serving. This is going to be just a file, right? This is just a file. We're serving it with content type header, and then we say could not serve a static file path. There we go, and then we just exit. So we basically took this repetition and we put it under like a single function. And now what we should be able to do, we should be able to simply serve static file, right? So I'm going to actually remove everything after this line. I provide the request, then I provide the file path, I provide the index.js, and I say that the content type for this thing is going to be this thing. Text JavaScript. So let me actually grab it in here. So theoretically, this is everything that we should have in here, right? So serve static file, right? So, and in here, we can also remove this entire step and we can say serve static file, HTML, text HTML. Isn't that poke, right? So at the beginning you saw me like copy pasting shit like crazy, right? So just like instead of like making proper abstractions stuff like that, I'm copy pasting stuff. This is because I'm figuring out the patterns. I figured out the pattern, so here is the pattern, right? So and now every time I need to like serve a certain resource, I just say okay, serve static file. Interestingly, what I'm thinking is that maybe we could do like a separation between different methods, right? Some sort of a separation between different methods, right? So maybe match request method first, right? So then method get, all right? And within the method get, we can match request URL. And here we can already have the situation where you just have these two things and the index.html. Right, and you would serve it like that. But then that means we will have to have a situation when we'll have to put 404 in two places, right? So we'll have to put 404 into places, so it's not particularly great in my opinion. So I also have an idea of actually serving 404, serve 404, right? So we provide the request, we actually move in the request inside of this entire thing, right? So this is the result. There we go. And I'm gonna be literally moving this thing in here. All right, and because of that, I can just say, okay, serve 404 for the request, right? And I don't need this okay anymore. So as you can see, each branch returns the result. Maybe even don't need this specific block, so I can just like compress these things into a single like thing like that, but it's actually kind of too much, right? It's not particularly visible. Yeah, I think it's a little bit better because this particular branch is like too long, if you know what I mean, right? It's a little bit too long. Anyway, so let's try to go through the compilation errors just to see if we didn't do any significant wacky. Okay, so all right, so this is the result, and then at the end of this entire stuff, interestingly here we can just return that, right? So we can just be like this. Anything else? Okay, so this is another stuff and we can just return that. Anything else? All right, it is working, it is working. So if I refresh, if I try to find this, it doesn't work. Index.html works, index.js works. Okay, so that's pretty cool. So as you can see, we were starting to sort of like develop our like small framework. I mean, framework is a very strong word for this kind of thing, but you know what I mean, right? And like in the future, if we'll need to add more things in here, it should be relatively easy to do. Then we can start using like regular expressions on the URLs and dispatch and stuff like that. So yeah, that's cool. Isn't that cool? Isn't that cool? I think it's pretty freaking cool. So we've got a sub from Tsar Jakob. Thank you so much for Twitch Prime subscription with a message. Let's give some money to our poor man, Jeff Bezos. Always love your content. Yeah. You imply that I am Jeffrey Bezos or something like that? Is that what you imply? No, I'm not Jeffrey Bezos yet. Alrighty. So let's go. So what kind of stuff do we wanna be able to handle, what kind of stuff do we want to be able to handle? I want to be able to handle maybe some sort of like an API call, right? So specifically maybe post, right, where we have API and basically search, right? So essentially search, and we're gonna submit like a text in there, and then we're gonna perform the search within the index. Within the index, okay. So how are we gonna be doing all of that? So let's take a look. So we need a way to get the body of the request, right? So we need a way to get the body of the request. Let's see how we can do that. So if we take a look at the request, it must have some sort of a body method, right? So body, where is the body? There's no way to get the body. Okay, so the body of the request is large enough. Handling request piping requires certain body if the body is too big, tiny HTML will avoid doing that. I don't get it. So it doesn't handle the body? Right, so the body of a request is large enough. Handling requires pipelining requires storing the body of the request in a buffer. If the body is too big, tiny HTML will avoid that. Or pipelining, it's not really about body. Sends multiple requests in a row, yeah. To body length. Okay, so we have a body length. Upgrade as a reader allows to read the body. Okay, so you can basically take the request and convert it to a reader, and then you can read this thing from this thing. Okay, that's cool. So what I'm thinking is that, is there any way to convert a reader, like read everything from the reader? So this is a good question. This is a good question. So Rust up doc. API, let's find API. So essentially I have a reader. I just want to print whatever is located there. So one of the things I can do, I can try to read everything from the reader. Right, so I'm pretty sure maybe there is something in IO. Read. Yeah, you can just like straight up read. Is there any way to read all? Okay, so let's just take a look at the read. Maybe read actually reads everything from here. Okay, so you read into a mutable buffer, into like a single chunk in there. Okay, so there is a read to end, which is nice. Read all bytes until end of file. That works, I suppose, that works. So now we'll need to create a buffer, I suppose, right? So this is the buffer and the vector, new vector, right? So we have a buffer, so it probably has to be mutable. Then I take the request as reader and I read to end. I read it to end into the buffer, right? Into the buffer, right? Can I now convert it into a string? I don't remember. There's like several ways to do this kind of stuff, right? Body, right? So this is the body. So let's put it this way: search body. And can I just do into string? I don't know. Like this is me for the first time programming in Rust. All right. So if anything, we can always just like iterate and collect it into the string. So yeah, it has to be body like this. Body not for oh, this is because it's a buffer. Yeah. Alright, what do we have? It has to be mutable. It has to be mutable. A reference, of course. Alright, what else do we have? Okay, into... Well, it doesn't really know. Can I just collect? Cannot be built from integrator over. Okay. So we probably have to do clone or something. Freaking Rust. vec of bytes to string. And it's just like it's different every time, right? So there's so many different like ways. I can never remember like which one do you want today? Which one do you want? Okay, str from UTF-8. We can try to do that. Yeah. So sure. Str from UTF-8. Yes, look how nice our language is. There's hundreds of ways to convert between hundreds of strings. Oh my god, isn't that amazing? That's why you have to use our language. That makes it safe. Okay, no associative function from... Is that because... So it has to be slice, but I'm not sure. Okay, let me take a look at the documentation from str, right? So let me take a look. So, yeah. str from UTF-8. I just want to take a look at what exactly does it say. The signature, right? So it's just, oh, because it can actually fail. All right, so that makes sense. Okay. I might as well, by the way, just do that, and if it fails, I'm gonna say, yeah, that's actually kind of cool. Yeah. I'm gonna say eprintln error could not interpret body as UTF-8 string because of this, right? So, and we're gonna just simply log that, and that will bail out. And look at that! Look at that! Isn't that better? From str, do I have to? Oh yeah, god damn it! I was thinking like, what the fuck am I missing? I'm missing to just like importing this thing. What else do we have? Mismatch type. So, and in here we're supposed to then return. Yeah, we're supposed to return something, right? So we're supposed to serve something. We can do request response from string. Okay, we can just respond with okay. Map error, error. Request is mutable. Okay, that's pretty interesting. So it needs to be mutable like that. Expected type, so it has to be part of this thing. Okay, cool. We did it. All right, that's cool. Where is this shit? Where is this shit? So I can try to do API search, and it should return 404. It should return 404. Right, and this is because the search has to be post. Right, so the thing we can do now, we can go to index.js, right? We can go to index.js and we can try to fetch, we can try to send something in there, right? So I don't remember how to use fetch, so let's go ahead and do that, like JavaScript fetch. So fetch API, All right, so already went there. So you can just query something, but how do I do the post? Okay, so you can provide the post. You can say that method is post. I'm going to copy paste the entire thing. Motherfucker. Okay. So mode course. Do I care about any of these things? No. Okay, we can leave them. So application JSON redirect flow. Okay, so we can provide some hello, maybe, I don't know. Let's put it this way. Hello world. All right. So fetch, if I remember correctly, returns by itself, returns future, right? Oh, it's called promise. I'm sorry. It's called promise, and then we'll have to print. Okay. Then response, and let's just do console log response. Okay, that's cool. Where is the URL? Okay, if I got to do the following thing, so I need to do API search. Right, so we do API search, querying API search. Okay, so let's try it. I don't really need to refresh this entire stuff, so let's go and just refresh this thing. Right, so we need to go to here and did a request. Would you look at that? So query an API and we get a response, and response contains does it contain body? Okay, so here's the body, and what do we have in the body? We probably have nothing, but let's take a look at the logs. Yeah, well, there you go. Okay, so we got some data from the client. Isn't that poggers? Isn't that poggers? I think it's pretty fucking poggers. All right. Do I need any of this crap, honestly? Okay, I don't. That's pretty cool. Fuck all of that. Okay, that is powers. So what we can do, actually, we can do something like query, and let's try to search something, right? So let's try to search something. Can we say bind texture to buffer, right? So because we're searching within the OpenGL documentation, right? We're searching within the OpenGL documentation, so I'm gonna use like OpenGL-ish words, and we'll try to like comprehend them. We'll try to understand what the hell is going on. But I wonder if it's gonna be just text, right? If it's gonna be prompt. Do I really need to use JSON? Because I don't really want to parse JSON right now. So can I do bind texture to buffer to buffer, and I'm gonna say how do you do plain text? Content type plain text. Keep forgetting. It's something text slash plain or plain slash text. I can never remember the order. Text slash plain. Okay, sure. Being a web developer is really hard. You have to really remember all of this, like plain text, text plain. It's just so freaking hard. Like it's easier to memorize like all of the x86-64 instructions, in my opinion. It's just like way smaller set of things that you have to remember. All right, so what do we have? So this is going to be text plain, and I wonder if this is going to still work. Right, so this is the stuff that we got, and I'm gonna refresh. Right, so bind text to buffer. Okay, so that's cool. So this is what we got. So let's go back, and one of the things we can do in here, right, so this is the body, right, so this is more of a query, right, and we can do a very cool thing in here. We can try to tokenize that mother flipper. Right, so we have a special tokenizer that actually tokenizes the documents, right? Right, and then we need to do the same thing for the input of the user, right? So we have Alexa, right? So here's the Alexa, and we actually accept the sequence of characters. So that means we'll have to turn it into a characters, right? And then collect all of that into a vector, right? So we're collecting that into a vector. So then later I can do Alexa new in here, and then we're gonna iterate through all of the tokens, right? So token in, and each individual token, we can try to print that thing. Right? Let's just do it like that. Cool. So that will require restarting the entire thing. And if I refresh, here are the tokens. Right, you remember how in JavaScript we provided the the search query? So this is the search query, and we split that into the tokens. But here's the interesting thing: we also, when we index the files, right? When we index the files, we also bring the tokens to the uppercase, and this is not part of the lexing, right? So TF index of folder, I think we should change that. I have a feeling that we should change that. So as you can see here, we're iterating through the tokens, and then we're bringing them to uppercase and converting them to a string, right? I feel like the tokenizer itself must do that. That's what I feel like. The tokenizer itself must do that for us. So we'll have to do a little bit of refactoring. So if I take a look at the token, struct token. Where is the token? Oh, okay. So the next token, it just returns the slice of characters. So let's actually return. I think what's going to be the best way to do that? Yeah, let's return the slice of strings. Yeah, there we go. So we've got some subs. Frothy Nix, thank you so much for Twitch Prime for 6 months. Thank you, thank you, thank you. Without any message, but no message required. Thank you so much. Really appreciate that. Really appreciate that. Okay, so if I'm going to be returning strings, so let's actually do cargo build, just to build things around. So this is that. So we chop while, and then what I need to do, I need to probably map, map to uppercase and then collect it into a string. I can just map it and collect it because it can infer the type of the string, right? So I can just do collect and it will just infer that, hopefully. We'll see. What else do we have? It's a double dot, nothing particularly special. Not an iterator, so that means I have to do iter first, right? Alright, so that worked. That worked. But what's funny is that I don't think we need to have that for the for those things. So we also need to do that. We only need to do that for alphanumerics, right? We're only gonna do that for alphanumerics. Let's put this in here. But now we also need to convert that stuff. Can you do toString in here? No, I can't do toString. Okay. Alright, what else do we have in here? So next token, so this one has to be a string. So, and in here, we don't even have to worry about that because token is already that. So that means I can just even do term and just pass it like that. So that kind of simplifies shit even more. Yep. Oh, well, man. We have to do it like this. That's poggers. That's even poggers. Okay. So in here we just do that, and I don't have to do it like this because I can like straight up print the entire stuff. Okay. So let's do run. Actually serve. Right. Well, let's do serve. Run serve. Yeah, boy. And there we go. So the query, the initial query was bind texture to buffer, and we got bind texture to buffer. So, and interestingly, we can put some stuff in here, like some spaces and dots, commas and stuff like that. And we can refresh this entire thing. And let's take a look at the tokenization. Yeah, okay, so it tokenized that properly, right? It separately recognized comma and dot, and we can now do computations for these things, right? All right, and here is an interesting thing. So now we can try to rank the documents that we indexed according to the query words, But to do that, we need to be able, we need to have the index, the term frequency index. So we have to accept TF index, which is term fric index. I'm going to accept it by immutable reference, right? So, but to be able to pass that thing, we need to read it first, right? So we need to read it, which means that we need to accept the index file, right? So here, we, as you can see, we accept the address, and I think as first thing in here, we're going to accept the index file, and it's going to be mandatory, right? So this thing is going to be mandatory. So I'm going to also adjust things like that. So as you start into serve, we expect you to provide an index file as the first thing. Then we need to read that file. So we open the file and then we use Sergi to read it. So we can just like grab this stuff. Right, so we read the index file, right? We open that file. There we go. Then I'm trying to parse it. There we go. And now we should be able to have a thing that we can always pass to the serve request, right? So this is going to be TF index. Now we always have that thing in there. So let's do build and go to the compilation errors. So when I open in this thing, so index path, it's not a string, is it? So I probably have to do like that. Yeah, there we go. Okay. Cool. So we have everything. We have everything. So we can now finally do the cool thing. Right. So as already mentioned at the beginning of the previous stream, we're using TF-IDF to rank the documents, right? So this is what we use. So term frequency, inverse document frequency. So basically the term frequency tells you how frequently a certain term appears in a document, in a specific document, and then tells you the relevancy of that term for that document. Inverse document frequency is basically how often that term appears in other document that is not the current one, right? And you take the term frequency and divide it by inverse document frequency. Right. So the idea of this operation, which is kind of a weird operation, why the fuck would we do that? If you have a term that is very frequent in one document, but it's also frequent in other documents, you're gonna end up with a ranking that is very small, because that means that this term is just a noise. For example, one of the frequent term that happens in all of the documents is a dot or a comma, just a punctuation sign. And because of how we treat all of that, and articles word, yeah, exactly. So the chat says article words, and because of that, all of that is just filtered out by that formula automatically, and it only focuses on the important terms, right? So maybe there is a term that is happens very frequently in one document, but never happens in any other documents. So what that means? That means you're interested in that document, right? So obviously, right. So what we need to do, we need a way, given a term and given the table of frequencies, to calculate the term frequency for that thing, right? So what we have an interesting map, right? We're mapping file path to term frequency, and term frequency is a mapping from term to how frequent it is. So here is the map of this, all of the documents and stuff like that. Search. Search. I need a function, right? I need a function. I don't know how to call this function yet, but it's going to accept a term, right? So it's going to accept a term and the term frequency table for one document, right? So it's going to be term frequency. And it's going to return that value, right? So that value. So in Wikipedia, we even probably have how you do that. Okay, so here's the term frequency. So essentially, term frequency, you take the frequency of that specific term in that specific document, right? and then you divide it by the sum of all of the frequencies within the document, and there you go, you got this sort of like a percentage that you can use. So that means we have to return floats in here. So TF, let's just call it TF, right? So we got a bunch of gifted subs from Balnus. Thank you so much for 5 gifted subs, I really appreciate it. Thank you, thank you, thank you. Alrighty. TF, I don't really know how to call such function, that's the problem. TF of, because this is a TF table, right? So this is a TF table, so it's kind of difficult to name this thing, but effectively we're computing that, right? So it's a term, and this is the document. Oh, okay, so this is a document, right? We can call it like a document. D and T, right? So it's a term and document, right? So that's pretty cool. So we need to compute the sum of the frequencies in the document, right? So we'll have to iterate them. So it's a pair of a term and its frequency, right? Term and its frequency. We don't care about the term itself, we only care about the frequency, right? And I wonder if I can just do maybe map f, just extract this out and just sum. Right, so I'll just call it sum. I wonder if I can just do that. That would be kind of cool, I think. Right, and then we need to take the frequency of that term, right? So we need to take the frequency of that term, d, get, we get in that term, and what's interesting is that what if we don't have that term? We can treat that term as having frequency 0, so that means we can do unwrap or 0, right? And we need to divide all of that by sum, right? So maybe we can even do it like this. Oh, that's actually pretty cool, I think. Right, and then as 42, as 42, and that's the whole formula. Right, so this is the upper part of the formula in here, and this is the lower part of this formula in here. Right, and it's a very declarative way of doing this thing. It's a very declarative. All right, but this is only for for a single document, right? This is only for a single document. Map or so that means you have to make it cloned. Yeah. Is not an iterator. You want to iterate this thing. It's a tuple. It makes it even more complicated. Some cannot be inferred for some blah blah blah. Okay, I see. I wonder why it cannot be inferred, because it's a use size. Why couldn't you infer that? You literally have that information in there. Why couldn't it infer that? It's so weird. But yeah, anyway. So what I'm thinking is that I probably need to, I want to take a term and go through different documents and just test how that term works in there. You know what I mean? Reval1111, thank you so much for sub. Thank you, thank you, thank you. Thank you, thank you, thank you. I feel like I need to make a small break yet again. I feel like I need to make a small break yet again. Yeah. It's not particularly pretty, I don't like that. But I ran out of tea, so I won't be able to make another cup of tea, unfortunately. So yeah. Let's make a small break. Let's continue, I suppose. Let's continue. I want to have a smaller set of documents, right? Because right now, So the problem here, what's the actual problem, is that the JSON, this is not what I wanted. I wanted to do JSON, right? So the index right now isn't intensely huge, right? I can't test whatever I want to test on that index, on that huge index. So what I'm gonna do, I'm gonna rename this thing to big, and I'm gonna create a smaller one, right? We're gonna create a smaller one, and the smaller one is gonna be basically like a small set of documents, maybe like 5 documents, right? So let me put it in here. So let's take GL4, and let's just take a bunch of things in here, right? So maybe this amount of things. I hope this is representative enough. No. Let's actually pick different things. One with A, one with B, and maybe one with clean. So something with compress, like different topics of things, right? You know what I mean? And let's just copy paste them. So we have 5 documents. And let's index specifically these 5 documents, right? So this is going to be small. Right, there we go. So we've got the JSON file, a smaller JSON file. We can even open it in here, right? So if we take a look at the search index JSON, it contains 5 files, right? So if I try to serve this specific thing, right? If I try to serve it, what can we do now? Right. The thing I want to do is now iterate through each individual document, and for each document, compute the TF of each individual term. So it's going to be like 2D loop, a nested loop rather, right? So let me find serve request. So here is the serve request. So here I iterate through each tokens, but what I need to do, I need to iterate through each documents as well, right? So this is the TF index, and here we have a path and TF table for that specific path of the document, right? Right. So TF table. And for each of these things, so I might as well even do println, right, path. And as far as I know, path is literally the path of Rust, which means that if I want to display it, I have to call this thing. Right, so like so. Then I'm iterating through each individual token, and now I have to compute that TF thing. I need to compute that TF thing. So TF takes the token, right? So I might as well, yeah, I might as well take it like that. And the TF table for that stuff. And I might just like go ahead and print the token first, and then its relevancy for that specific document, right? So it's TF. And let's see if it's going to work. So I need to refresh the entire thing. Surprisingly, it compiles. Okay, I'm gonna refresh this stuff. That's pretty cool. So what we did in here, we went through all of the documents, and we can see that the term bind is completely irrelevant to GL attach shader. Texture is also irrelevant. Buffer is also irrelevant. Dot is also irrelevant. Right. What's interesting, we have GL clear buffer, and the buffer is actually rather relevant to this specific document. So might as well maybe like space it a bit more. Okay, that's actually pretty cool. I really like where we're going with that. So this is not what I want. I want you to just wait. What? Why are you indexing? I want you to serve it. Okay. Cool. Yeah. So what I'm thinking is that we probably need to sum them up, right? We probably need to sum them up. And basically that way we'll know to which document this thing is the most relevant. Which document it's most relevant to, right? That's how you speak English, I think. Okay, so, and we can do something like total TF, and it's mute. total TF, but we should compute that for each document, right? So this is going to be that, and we just iterating through the token. We compute for this entire thing, and I suppose we'll have to do total TF. Yeah, I really like that. So it doesn't compile because semicolons in 2022. This one must be F32. Okay, we're getting somewhere. All right, so we have query bind texture to buffer. Bind texture to buffer. What's the most relevant document to that? The most relevant one is GL copy texture sub image, which is rather interesting, right? So because we're talking about textures and it brings up the texture, which is right. And I wonder how it's gonna change if we remove the texture. It would be probably better to actually sort them by that specific value, if you know what I mean, right? So let's actually do that. Right. So we may want to have something like result, which is a vector of paths, right, of paths and their corresponding TFs, right? So it's going to be F32, and this is new essentially, right? So we're going to be collecting all of these things, right? So we're going to result push path and total TF, right? So this is total TF, and then after that we probably want to sort this kind of stuff by a specific key, and the key is the second value in here, which is the TF, right? So TF, it's more of a total TF, total TF, and after that it probably makes sense to reverse that, right? Because it's gonna sort them from the smallest to the biggest. We want to actually sort them from the biggest to the smallest so we can see them at the top. And after that we're gonna be looking through, let's call it rank actually, and also call this thing rank here as well in result, right? Print ln path rank path display. There we go. Okay, so it doesn't compile because why? This has to be a tuple. What else do we have? Push, it has to be tuple as well. What else do we want? Sort by key. F32 is ORD is not specified. Really? You wanna tell me that this is an unsolved computer problem in Rust? I suppose one of the things we can do, we can just sort by, where you have two ranks, and you just like compare it yourself. Okay, so Rust is just being a coward, right? It doesn't want to handle the comparison of the float itself, right? So, but since we can now do sort by, I can do something like rank 2 and not reverse it, right? So I can try to do something like that. Oh yeah, and it has to be. Can you just freaking Rust? I swear to God, why are you being so anal about such a minor thing? Holy fuck. Okay, Rust sort flows. Is there any like a common thing that people do, or is it really has to be so fucking anal? I know that floats are hard. I know that comparing floats is a dangerous thing. I know that. I know what I'm doing. Just like leave me alone. Okay, so there's a partial CMP. Fucking damn it. No, it's dangerous. Did you know that it's just partial comparison? Like, fucking no. Okay. Oh, and it's option, and you have to even unwrap this motherfucker because some weird shit. For fuck's sake. This has to be... it just pisses me off. Okay. Alright, so let's do that. Okay, cool. And it didn't... Yeah, so... I forgot that I changed the order, now I have to reverse it. All right, so we're at the top now. Okay, we're at the top now. So at the top, we have a copy texture sub image, right? And if I remove texture, right, if I remove texture and now refresh it one more time, right, now at the top, for the query, we have attach shader, right? So we removed texture, and now the thing that was about the texture is actually down below in here, right? So yeah, so as you can see, we actually like have a proper ranking and whatnot. But this is only TF, right? This is only TF. There's also inverse document frequency. So let's take a look at it. It's a little bit more complicated, but we'll try to figure out. Okay. So essentially, we have a term and we have all of the documents, right? So it's a term across all of the documents. N is the total number of documents in a corpus, right? So it's the size of the corpus. Then this is a number of documents where the term T appears, right? Number of the documents where it appears. If the term is not in the corpus, this will lead to the division by 0. It is therefore common to adjust the denominator by +1. Okay, and the final thing, you just multiply them together. So it's already kind of inverted, because the percentage of documents it appears would be computed by taking this value and dividing it by n. But since we are multiplying it with TF, we're basically dividing it, but it also takes a logarithm of this thing. Right, it's more of a logarithmic. Obtained by dividing the total number of documents by the number of documents containing the term, and then taking the logarithm of that quantity. Not sure what about the logarithm. It is a logarithmically scaled inverse fraction of the document that contains the word. Okay, plot of different... Okay. I don't really understand why it has to be logarithmic like that, but this is because I'm dumb. So I'm gonna just treat this thing as the black box. But maybe I can think about it. All right, so so logarithm usually has a base, right? And logarithm asks the question to which power I need to rise the base to get the value under the algorithm. So essentially it probably, yeah, what it does, it doesn't let this thing grow too fast. Yeah, I see what's going on. Yeah, I think I know why it is logarithm, because if the term occurs in a few documents, right, the value is going to be extremely huge, right? The value is going to be extremely huge. So we kind of bringing it, like, we're scaling it sort of down, right? We're sort of scaling it down with the logarithm, right? So with the logarithmic scale. Okay, I'm not a mathematician, so I'm not really familiar with this sort of like framework or thinking. It's a way of displaying numerical data of a very wide... I guessed it! The fuck? I understood what is a logarithmic scale through just reasoning about the definition of algorithm in this formula. Right, it's a way of displaying like large numbers, right? So, okay, so if you have large numbers, it's just easier to do that on logarithmic scale because its growth is sort of slows down. Right, so the bigger it becomes, the more it just slows down, right? And again, this value may become huge, right, if you have a lot of documents and stuff like that. So, but I'm not kind of sure why. Oh, since we have a small little thing in here, and we want to divide it by inverse frequency, we're effectively multiplying it by upside down fraction, but we scale down that fraction with logarithm. Interesting. Very interesting. It's just like math sometimes feels for me like programming, but from alternative universe. It's like if programming was invented by aliens. That's what it feels for me every time I do math or something like that. You know what I mean? Right? It's just like it has a lot of like similar concept, but it's like they're very alien for some reason. Maybe programming for mathematicians feels like that. I don't know. Right. Okay. Alright. So now I even understand what the fuck is going on. So the IDF should be relatively easy to do. Alright. So IDF, right? So we accept the term, right? We accept the term, but here we accept all of the documents, right? So we're gonna take term, frequency, index, and this is gonna be an inverse one. Okay. So and the total document in the corpus, right? So it's super easy to compute. Because it's literally the length of this thing, right? So how many entries we have in here, that's how many documents we have. So, but maybe it would also make sense to convert it to F32. And now we need to compute how many, in how many documents the term appears, right? So let's call it maybe some sort of like a count, right? So this is going to be count, and it's initially 0. So I'm going to be iterating through the document. So so this is more of a TF in D, right? Then TF contains the term. If this thing contains the term, I just do count +1, but maybe I can do all of that using Suskell, if you know what I mean. Right, so this is a very imperative way of writing this entire thing, but maybe I can use the Suskell way of doing that. Suskell. Okay, what was that? I forgot. Yeah, hash map. Iter. Not really iter, but I want to take all of the values. Right. So I can take all of the values. That's pretty cool. And it iterates through all of them. Right, yeah, okay, so I can do values, then I can filter all of them where the TF contains T, and then I can count this entire stuff. Right, let's just call something like M as F32. And effectively, we want to divide one by another, so we return N divided by M, but then we have to do the logarithmic scale. I'm going to do that after I test the compilation stuff. Right. So, expected to this what? I don't understand. Mismatch type. Expected struct found. What? Values. All right. So I have okay. I take the values and I filter. Yeah. Okay, cool. No method contains. So contains key. Okay, that's cool. That's precisely what I want. Okay, so speaking of logarithmic scale, what the base of the logarithm? What's the base of the logarithm? I suppose maybe in this case it's just 10. But I'm not quite sure. All right. So where is the stuff? Log. F32. So if we're going to be doing F32, log 2, log 10. I have a feeling that we have to do log 10. Yeah, I have a feeling that we have to do log 10. Log 10. And that should be it. Okay. So we have TF and IDF. Right. And the way we work with all of that, right, so we can probably think about it in terms of like a ranking, right? So we iterate through each individual document, right, and we compute the ranking for them. All right, so this is the rank. Then we multiply it by IDF, where we provide the token and the TF index, even though we're iterating this index right this instance, but since we're referring to it by immutable reference, this is totally fine. And this is basically rank. Okay, that should be it, I think. Let's give it a try. So I'm gonna rebuild it one more time. And it works, surprisingly. So let's try to serve the index JSON. Oh my god, run serve JSON. And let's refresh and let's take a look, and it failed at unwrap at 2028 precisely here. Okay, so and partial compare fails usually when does it usually fail? Partial CMP. Okay, partial CMP, let me see, when does it usually fail? So basically for some situations it's just none, it became none. Okay, so I'm gonna remove the sorting and let's see how it is going to work now. Yeah, all of them are none, right? So, and this is because, yeah, okay, so as it was said, if the term doesn't happen anywhere, usually what people do, they adjust it to +1. Right, so maybe this is one of the things that we want to do in here, just like do +1, or maybe put +1 in here. Yeah, so let's give it a try. Let's see if it's going to fix anything. All right. Okay, so it worked. And funny enough, it's kind of negative. I'm actually surprised. What the fuck it's negative? Wait, what? Huh. Is it because of the... What? That is really weird. Huh. So logarithm... Oh, logarithmic... Logarithm, because if value is too small, the thing may be... yeah, the exponent. I forgot the English. Exponent may be negative, yeah. Alright, so that's totally fine. So, and Wikipedia is totally okay with that, right? So the Wikipedia is totally okay. A high weight is reached by high term frequency and low document frequency. Of the term in the whole collection documents. The weights ends tend to filter out common terms. Since the ratio inside of the log function is always greater than the code, the value of IDF is greater than or equal to 0. Since the ratio inside of IDF's log function is always greater or equal to 1. No, in our case it doesn't seem like it. Because Alright, so I need to... This is not true for us, straight up. This is not true. Let's put it into X. Alright, so let's put it into X, and what I want to do in here is effectively just print path to rank, and path is path display, and rank is equal to X. Right. But this is for a single token. Right, so we have to do a token, and this one again 1, 2, 3, 4. What I want to do, in fact, here is just do ADF println path. Okay. Need to extract it. Okay. So this is not true. This is straight up not true. Like, they cannot be negative. So this is really weird. Right, so this is IDF. Let me see. Do we even do that correctly? So we filter only those that contain that thing, and then we just count them. And can I simply print what I want to do? I just want to see the actual values in here, right? So what are the actual values that result in something like this? I want to be able to debug that. Okay. Yeah. Really? Are you telling me? Oh. Ah. Are you freaking serious? Wait. Number of documents in the corpus. Is that a freaking mistake in Wikipedia? Right, because this will result to this thing potentially being bigger than n, thus being smaller than 1, thus making logarithm negative. Is that a freaking mistake in Wikipedia? I mean, I understand what they're trying to do in here, but the description, the whole description is kind of weird. So this thing contradicts with this thing. You know what's funny is that sometimes you open like a Wikipedia page with a lot of like math. It's like mad amount of math and just like you can't understand shit. And then you try to look inside of it and you get this shit. And it makes you like doubt, like really? Okay. So what we can do in here, so maybe we can just like literally somehow adjust if this thing becomes 0, or I don't know, if we can always do something like not +1, but can we do max between that and 1, right? Or maybe even count max 1. Yeah. Okay, so max. But do we have max? Oh, it does exist for F32. But does it exist for, I don't know, use size? Max value. It doesn't, it's only for F32. Okay, let's give it a try, maybe it will. Let's just build. Okay, so I think I'm already tired. All right. I think I'm already tired. Okay, so let's try to serve this entire thing. Alright. Oh, this is actually kind of cool. They're so frequent they end up being 0. Really? Well, I mean, probably maybe too small. Yo, I really like that. Look at that shit. So it kind of like, yeah, it figured out noise and important. This is so cool. Look at that shit. Isn't it cool? Isn't it cool that it's just filtered out the noise? Right, so because all of these things are noise words. Right, this is so cool. Okay, so I'm gonna go to index.js and bind texture to buffer, right? And let me see. Yeah, okay, so texture is also has some weights in some of the documents. It's pretty cool. Alright. So now I think we can try to compute the rank properly. Right, so let's actually do the rank. TF-IDF. So we're not going to sort it for now. Oh, we didn't print it. Okay, we're going somewhere. So attach shader. So the most relevant thing is GL clear buffer data. Right, because it probably contains like buffer and textures. Okay, good. So now let's also sort. Let's rank all of that shit. Okay, look at that. So the clear buffer data is the most relevant thing to the query bind texture to buffer. So the second relevant is copy texture sub image. If I remove texture from the query, right, now the most relevant, well, I mean, it didn't really change much, right, because it's about buffers and stuff like that. Okay, so one of the things I want you to do, actually, I want you to try to do something more, work on a bigger piece of data, right? So let's try to work on a big piece of data. And to make it manageable, let's actually display only top 10, right? So we're gonna take 10 and we're gonna display only top 10. Right, so right now we only have like 10 documents. Right, but what about having thousands of documents, right? So if I check index.json, as you can see, there's only 5 files in here, but we have a index big, which contains 1611. 1611. Right. So what if we try to search within that? And I wonder how much time it will take, actually. Right. So let's try to serve the big file. Serve. Okay, so it's parsing it first of all, right? It needs to parse, and now we're listening. Okay. Okay, it's taking some time to actually compute all of that shit. It's rather slow, which is fine, but if it computes, like, think properly, that would be cool, I think. It is doing important work, that's right. Oh wait, it worked. So these are top 10 results. Bind vertex buffer. Right, so the query was bind to buffer. Okay, bind vertex buffer, bind buffer base, bind buffer, and stuff like that. Right. So what if I add the texture in here? Right. So this was, let's actually save all of that. So this is the result for, for this thing. Right. So this is what we got. And now we're gonna try to do the same thing, but for texture. Right. The same thing, but for texture. All right. All right, we're waiting. It is not slow. It just cares about UX. Yeah, exactly. It's really interesting. Like, I wrote a pretty straightforward thing, and pretty straightforward thing in C, for example, would be actually rather fast. Why is it not really fast in here? Okay, so bind texture. Pretty cool. So that's pretty cool. So bind to buffer, GL bind vertex buffer, GL bind buffer, GL bind buffer, bind texture to buffer, GL bind texture, GL bind texture, blah 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 blah. Right. That's pretty cool. Yo, that works. That entire like ranking metrics actually works. It's really cool. Yo, it's fucking slow, but it works. And I always wanted to try it out. Yeah, so what else can we query? What else can we query? So what we can search for? So I want to search for a thing. Okay, GLSL function linear interpolation. Right, GLSL function for linear interpolation. Can I find one? All right. Time to profile. Yeah, probably. But I mean, we don't really have that much data. That's the problem. Like, we have only thousands of documents. And iterating through thousands of documents is not that big of a deal. I mean, come on. The fuck? Smooth step. It's kind of close to linear interpolation, not gonna lie, and also mix and stuff like that. Well, I mean, yeah, that's pretty cool. Look at that. So it found a smooth step. If you try to Google a GLSL smooth step, it's kind of a linear interpolation, but really not. The closest thing to linear interpolation, I think, mix. Right. Smooth step perform, yeah, Hermit interpolation between two lines. That's so cool. Yo. So, GLSL mix. So the closest thing to linear interpolation is mix, as far as I know. Yeah, linearly. Ah, okay. So we probably need to stem the tokens. Linearly. Yeah, if I put linearly in here. Let's put it this way. I think if I put linearly instead of linear, it will find it better. It will actually rank mix a little bit higher. Okay, so it's a little better. So now at the top we have smooth step and mix, right? Which is fair enough, right? So you're trying to find how do you do linear interpolation in GLSL, right? And that's what you get. And this is what you get from a program. that is running on your computer, right? It's very unoptimized program, but still it's running on a computer. You own all of the data. It works without the internet. It works without the internet. It doesn't send any of your data to anyone. You own the complete thing. You put just like, how do I do linear interpolation? Gives you that. So it doesn't need to observe your behavior and understand your preferences to just give you relevant information. Think about it. It doesn't need any of you. It doesn't want anything from you except paying for electricity bills. It doesn't even need your internet bills. Because Mix uses interpolate a lot and SmoothTap uses interpolation a lot. Oh, okay, that's pretty cool. So I suppose one of the things to improve the search we can do is stemming, right? So is that what it is? Stemming. Morphology, yeah, in linguistic morphology, something like this. It's a process of reducing inflected words to their word stem. And the word stem, right, like original word. So we don't have to think about linearly, and stuff like that. It just reduced to a single thing that you can compare against, right? So we just like remove all of different forms of the same word. Right. And yeah, so we can do that. So basically, improving the performance of this thing, it could be done in the lexing step, right? In how we lex this entire thing. Next stream idea, yeah, probably. So we can read about that. So, speaking of performance, it fucking sucks. And what's interesting is that I have no idea why. Because, look, okay. 111 documents, sure. 5 words. Is that too much for a modern computer to iterate? I mean, how? Where do we get such a dog shit performance? That's the problem. XML parser is not involved in computing the ranking. Right, so like if we do like a brief estimates, like I don't see where this dog shit performance coming from. But maybe it's not really that important, so it's probably not the topic of today's stream. The topic of today's stream was to actually finally try out this, this ranking technique, and it actually worked really great. Right. So the next step I will do actually is to generate like a proper response to the query and just display it in there. And you know what's cool is that since this application running on your machine, right, if you have a sort of like a document that can be displayed in the browser, you can make the application open something for you, right? You know what I mean? Right, if you're, for example, trying to read PDF, but browsers these days can read PDF, but you know what I mean, right? So the application has like a more access to your machine than just a regular website, right? So it's not even a web application, it just uses web as the UI, right? Alright, so that was pretty cool. I'll see where I can get this project to. And yeah, maybe it's gonna become something useful. Doesn't Sqlite document every single word inside of it? No. I have no idea where it's coming from. I'm gonna blame Rust. I think Rust is just a slow language. Anyway. That's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you on the next stream. Oh, release! Yeah, that's right. I keep forgetting about that. Yeah. Let's do release. They intentionally make it super slow. Right, so let's actually try release. Okay, so let's try release. They intentionally make it super slow, so then during the conversation you can drop something like, have you compiled it in release? And everyone like, holy shit, I haven't. Release. Everyone's just, oh, super speed, super speed. So this is literally why they did that. To demo how well their optimizer works or something like that. Okay, so are you guys ready? It's faster. It's actually way faster. It's still a bit slow, but it's way faster. So it was slow intentionally. It was slow intentionally. Right. We optimized it. Oh, turbo speed, turbo speed. And yeah, it works. Okay. That's it for today. Thanks everyone, and I see you all on the next Azuzin session.